Okay, so here's beta. What's the sine of beta? Well, it's the sine of 2 pi over 3 minus arc sine of radical 3 over 4. So I use the difference identity for sine. This is the sine of 2 pi over 3 times the cosine of the arc sine of radical 3 over 4 minus cosine 2 pi over 3 times the sine of the arc sine of radical 3 over 4. The sine of 2 pi over 3, I know that right off the bat. That's radical 3 over 2 times the cosine of the arc sine, radical 3 over 4, minus the cosine of 2 pi over 3. That's going to be plus 1/2. The sine of the arc sine of radical 3 over 4, that's just radical 3 over 4. So it really boils down to now finding the cosine of the arc sine of radical 3 over 4. Alright, so let's go up here and figure out what the cosine of the arc sine of radical 3 over 4 is equal to. I'm going to call this, well, I'm going to call that gamma because that's what that is. I want to find the cosine of gamma. I know that the sine of gamma is radical 3 over 4, and I know gamma is an acute angle. Okay, so I know cosine squared of gamma plus sine squared of gamma is 1. And so cosine squared gamma, plus sine squared gamma is 1. So that means cosine squared gamma is going to be, well, let's see, 1 minus, square that, you get 3, square that, you get 16. I've got 16 over 16 minus 3 over 16. That's 13 over 16. So I get cosine of gamma is this plus or minus square root of that. So radical 13 over 4. And since gamma is an acute angle, I know cosine's positive. All right, so I can go back now to this expansion, and I get radical 3 over 2 times radical 13 over 4 plus 1/2 radical 3 over 2, and I get radical 39 plus radical 3, this is over 4 here, all over 8. Alright, so B equals 40 over radical 3 times radical 3 plus radical 39 all divided by 8. And this simplifies actually pretty nicely because the 8's going to go into that 5 times. I'm going to factor a radical 3 out of this, cancel that out, so I get 5 plus 5 radical 13. Okay, if you're allowed to use your calculators, we're given alpha and A. Gamma is the arc sine of radical 3 over 4. If you run that through your calculator, that's approximately 25.66 degrees, which means beta then you can take 180 minus 60 minus 25.66 degrees. That'll get you 94.34 degrees. And then you can use that in your calculator to get B to be approximately 23.03. So whether you do it exactly or with a calculator, that'll do it for part B. Alright, in number 2, we're asked to find the area of the triangle in 1A. And so in 1A, this was the triangle. We could quickly find the third angle, and then the other sides we could get using law of sines pretty directly. These were the exact answers, and these were the decimal approximations. And to find the area of a triangle, it's 1/2 base times height, and what we've seen is, what we can do is take the product of two sides of the triangle times the sine of the angle in between. So we're spoiled for choice. We've got all three sides here. I'm just going to stick with this angle 30 degrees. So I'm going to have the sine of 30 degrees. I'm going to have the product of the two sides here, which is tan and c, times that. So I'm going to have 5 times c, and c is this, times the sine of 30 degrees. And so I have 50 sine of 45 degrees sine of 30 degrees divided by the sine of 105 degrees. Now, as we did in part A, we could go through and find exact values for all these things, but I've already pushed the limit on this checkpoint quiz video anyway. So you can go ahead and throw that in your calculator and see what you get. And this will give you roughly 18.30. And remember, this is an area, so that's going to be whatever the units are squared. So that'll do it for checkpoint quiz 11.2.